Now we will solve right triangles. What do we mean by solving right triangles? That is, to find unknown angles or unknown sides. That is, for this given right triangle, as you can see, we call it ABC, right? This is a triangle ABC, and it is a right triangle because the angle C is a right angle. So then we label the corresponding sides as lowercase ABC. So the lowercase a is the side length corresponding to angle A. The lowercase b is the side length corresponding to the angle B. And C is the hypotenuse that is corresponding to the right angle. So we use this notation. It doesn't matter which letters do you use, okay? So we are going to solve a right triangle, such as this one. So this right triangle ABC, suppose we know the angle A, which is a 30-degree angle, and we also know the leg A, which is 8. The unit, suppose it's 8 inches or 8 feet. So it doesn't matter. So we all the units for the length, we adopt the same unit. So suppose we know the A is 8, then how can we determine the unknown angles? So the only unknown angle is B, and we know the A and the B are complementary because it's in a right triangle. So A plus B must be 90 degrees. So immediately, 90 minus 30, so we know the unknown angle is 60 degrees. So we solved for the unknown angle B. Now the remaining task is to determine the unknown side length. So that is B and C. So let's solve for B first. As we see that A is given, the lowercase a, and AB are related, right? Because of the tangent 30 degrees. So let's write an equation. Tangent 30 is equal to A over B, right? So the opposite over adjacent side. So 8 over B. That's the definition of the tangent of the acute angle, 30 degrees. Then certainly you can also write as B over 8, which will be cotangent 30 degrees, or reciprocal of tangent. So then we can solve. You pick an equation to solve. So this is an equation. Only the B is unknown. So the B quantity. So if we multiply both sides by 8, then the B is found to be 8 times cotangent 30 degrees. So therefore, if you remember the cotangent 30 degree is square root of 3. So that's the length B. But if you want to write in decimal form, square root of 3 is 1.7 something. So then you can get a decimal form, 8 times the square root of 3. So, but right now we leave it as the exact length in this form of the irrational number. So that is the B. Next, we want to continue to find C. The C can be easily found if you use Pythagorean theorem. That is, we can find C squared, right? Because you know A, you know B, and A squared plus B squared will be C squared. So C, the hypotenuse, is the square root of A squared plus B squared, which is 8 square root of 3 squared. So we can continue to get the 8 squared plus, so 8 squared times 3, because when you square the 8 times square of 3, and then that's a number we can continue to calculate. So it is 8 squared is 64. Then there's a 1 plus 3, that's a 4. Right? So we can see that the 64 is actually a common factor. Yeah, 64 is a common factor. I factor it out. So 64 times, after I factor out, then there's a 1 left. So 1 of the 64 plus 3 of the 64. So we have 4 of 64. So then we can simplify it, because you take a square root of 64, that's 8. And then square root of 4 is 2. So we get 16. 16 is the hypotenuse. So we have solved the right triangle because we found the B, we have found C, we have found the angle B. So that is the right triangle solved. Sometimes you can, but you have more than one option, because for this right triangle, after you get already a B, or before you get the length, the leg B, suppose you want to find C first, you can. Even if you do not know B, you can still find C first, because A is given. And we try not to use the intermediate values, because B, suppose you have 8 square root of 3. If you write in decimal form, right, it's approximately something. And then you get approximate values in that case. If you write in decimal form, then you use that value that can cause a round of errors for C. So we, if possible, we use what is given. So here, that's an accurate value that is given 1, and angle A is given 1. Can we find C? So that is possible, because we remember A and C, right? This ratio is sine 30 degree, because opposite side to angle A over hypotenuse, that is a sine 30 degree by the definition of acute angle. Or if you want, you can write C over A. And C over A, that is a reciprocal of sine, right? So that is cosecant 30 degrees. So you can choose to use either one. Then next, then the C because A is given as 8, then cosecant 30 degree. So it is 2, right? Because sine 30 is half. Cosecant 30 is actually 2. So then C can be found as 2 times 8. So we multiply both sides by 8. That's 16. So we found 16 by using the given information. And we didn't use the B, the value we found. So when possible, we try to avoid using the intermediate values that we have found. In that case, even if you make a mistake for finding for the B, then you can avoid using a wrong answer. So that is some practices. Now we look at the angle of elevation and angle of depression. So when you look up, for example, into the sky, suppose there's a little balloon, right? And then you are standing here. So this is a person. Yeah. So if you stand here and you look up at the balloon, and there's a line, this line of sight. So this line of sight and a horizontal line here, there's a acute angle. So this acute angle formed by the line of sight and the horizontal line. And this acute angle called angle of elevation. So sometimes you stand high, right, at a location, and then you look at an object, whatever that is, and then you see there is this line of sight here, line of sight, this line, and the horizontal line, and you notice an acute angle formed by the line of sight and the horizontal line. So this acute angle is called angle of depression. So either angle of elevation or angle of depression, and they're acute angles formed. Now, suppose you know angle of elevation, then sometimes you can form, actually you can always form a right triangle and in real life problems. So let's see. Suppose this picture H is the height of a certain building. So suppose this is a building and you want to discover the height of this building. And you're standing here and you look up at the building, the top of the building. So that's the line of sight. The line of sight, and you notice where's the horizontal line. So you just see this is a horizontal line. That's how far you're from the building, which is 70 feet away from the building. So 70 feet. And the acute angle formed by your line of sight and the horizontal line is 53 degrees. So how do we discover the height of the building? And we know the height. Let's just write an equation involving the height. The height of the building over 70. So this one leg, which is opposite to the acute angle 53 degrees. So h over 70 is what? Tangent 53 degrees. Tangent 53 degrees. So we have an equation here. H is the unknown quantity to be found. H is the height of the building. So in order to find the height of the building, you see, you don't have to go measure it, right? You just use the angle of elevation and your distance from the building, that horizontal distance from the building. And then you can get this equation. So how do we solve for h? That's very easy, just in one step. The height is, if we multiply both sides of the equation by 70, so 70 times tangent 53 degrees. But of course, you will have to find a tangent 53 degrees because that's a specifically given angle. And if you use a calculator tangent of this acute angle, you have a quantity. So we actually solve a right triangle, right, using the definition of acute angles, definition of the trigonometric functions of acute angles. So that is the equation we set up. And then tangent 53, 53 is not a special angle. So tangent 53 will be a quantity involving decimal places. And then 70 times that quantity is approximately 92.89 feet. So because 70 is the distance in feet, so we get the height of the building is approximately 92.89 feet. That is how high it is.